topic of this video is evaluating piecewise-defined functions. Let's look at a problem. Alright, here's what we're given. F of x is equal to x squared if x is less than 0, 2 if x is equal to 0, 3x plus 4 if x is greater than 0. Okay, so the first thing that I'd like to do in discussing this problem is to illustrate the idea of how a function works, especially when there are three pieces. So we've got three different sets of instructions here. F of x will equal x squared is the equation we'll use if the value of x that we're trying to plug into it is less than 0. F of x equals 2 is the equation we will use if the value of x we're trying to plug into it is exactly 0. And f of x equals 3x plus 4 is the equation we will use if the value of x we're trying to plug into it is greater than 0. So as you can see, depending on which value of x you're trying to put into your function, there are three different expressions for you to plug into. Another way of representing this piecewise-defined function would be to use this function diagram. Here's how it works. X is the input, and it goes into a machine named f. The very first thing that this machine does is it decides which set of instructions should be followed based on the value of x. If x is less than 0, then it will follow the instructions, square it, and send out an answer. If x is 0, it will simply send out a 2. And if x is more than 0, it will multiply it by 3, then add 4, and output that value. This diagram is the same thing as this algebra that I've written right over here. So hopefully by showing you these two different ways of representing the same information, I've given you a clear conceptual understanding of how evaluating a piecewise-defined function works. All right, let's go ahead and begin our problem. Find f of 4. So I'd like you to compare these two things right here, that and that. This is pronounced f of x. This is pronounced f of 4. What that means is that the 4 is sitting in the x position, which is telling me that for this problem, x is 4. Now, I can use that information to determine which one of my pieces I should plug into. I will use the top piece if x is less than 0, the middle if x equals 0, and the bottom if x is greater than 0. Well, x is 4. That's greater than 0. So I'm going to plug into my bottom piece here. So find f of 4 when f of x equals 3x plus 4. So I'm going to turn every x into a 4, and I'm going to use parentheses as required. So I get f of 4 is equal to 3 times 4 plus 4, which is equal to 12 plus 4, which is equal to 16. So I get my answer. F of 4 equals 16. Okay, next, find f of negative 1. So again, we're going to make the same kind of comparison. The negative 1 is sitting where the x goes. So this is telling me that for this part of the problem, x is now the new value, negative 1. So we go up to here and we figure out which piece to use. Remember, x is negative 1. So is x less than 0, equal to 0, or greater than 0? Well, it's negative, so it must be less than 0. So that means for this problem, we're going to use the top piece. So I can say when f of x equals x squared. Then I can plug in and replace both of these x's with negative 1. So f of negative 1 is equal to negative 1 in parentheses squared, which is simply 1. So this is the second answer to this problem. And then finally, that brings us to the third piece, find f of 0. Same approach. There's a 0 sitting where the x is, so this is telling me that x is 0. So which one of these pieces will I use? Remember, x is 0. Well, it's clearly the middle one, where it says x equals 0. So I'm going to plug into f of x equals 2, because that's what the middle piece is saying. Now, interestingly, this is the constant function. It says that when any input x goes into a machine named f, what comes out is 2. It doesn't matter what x is. So if you need to find out what's f of 0, well, it's just 2. And the reason is most clearly illustrated by this middle box of our diagram. When an input comes in, if the input x happens to be 0, you simply make it a 2 and you send it out. So the answer to part C is f of 0 equals 2. This is how you evaluate a piecewise-defined function.